Hi boys and girls, my name is Miss Gonzalez and today we're going to go over lesson 5.1 that goes over addition and subtraction of integers. An integer, the first thing we want to do is define what an integer actually is. An integer is a union of the negative integers, the positive integers, and 0 is a set of integers denoted by I. So if you look right here, we have I, and of course it's in this set. We have -4, -3, -2, -1, 0, 1, 2, 3, 4. So basically an integer is any number, whether it's negative or positive. Now, next we're going to talk about opposite. The negative integers are opposite of the positive integers. For instance, a -3 reflects a +3. If x is an integer, then the unique integer is -x, is called opposite. So we have two examples I'm going to give you right here. We're basically going to convert these from negative and positive and make it a unique integer. So right here we have x equals 7. So to make that a unique integer, it would be -7. You're basically just changing the sign from positive to negative. And then right here we have x equals -9. To change this one, we want to change it to a +9. So that would be its unique integer. Now we're going to talk about absolute value. The absolute value represents the distance of a number from 0. So right here I have this number line that I made. Say we're looking for the absolute value of -4 and 4. We have 4 right here. Then we have -1, -2, -3, -4. And as you see, they're both 4 units from 0. One thing to note is that a positive integer and a negative integer will have the same absolute value. And I'm going to give you some examples right here. Okay, so some examples showing absolute value. Let's see, let's find the absolute value of -5. The absolute value of -5 would be 5. Okay, another example would be the absolute value of 0. What's the absolute value of 0? It's going to be 0. And then one more. Let's see, what is the absolute value of just regular 5? Absolute value of +5 is going to be 5. So these are some examples of absolute value. Okay. Now, what we're going to do is go over integer addition. So there's different models that they use to kind of show integer addition, which are the chip model, the charge field, and number line. So if you look at the chip model, let me get a balloon red real quick. You're gonna put blue circles for positive, and then for the negative numbers, you're gonna put a red circle. Okay? And let's go ahead and figure out what these solutions are. We have -8 plus -3. So what we're gonna do is put -8 and -3. They're all gonna be red because they're all negative. So we're gonna do 1, 2, 3, 4, 5, 6, 7, 8. Then we have negative plus -3 is 1, 2, 3. So then what we're going to do is add everything because they're all negative. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So Negative 8 plus negative 3 is negative 11. Now, we're going to come do this one. We're going to do negative 4 plus negative 7. So, let's do 1, 2, 3, 4, because we have negative 4. Then we're going to do 7, and that's a positive 7. So we're going to do 1, 2, 3, 4, 5, 6, 7. And when you have a blue and a red dot, they all cancel out. So these cancel out, these cancel out, these and these, leaving us with 1, 2, 3. So our answer is going to be positive 3. Okay, now we're going to show you how to use charge field, which is almost the same as the chip model. The only thing that's different is we use negatives and positives instead. So for example, we have 2, we would do 2 positives. Then for negative 4, we would do 4 negatives. So 1, 2, 3, 4. So let's go to the first problem. We have 5 plus negative 3. So we're going to do 5 plus signs. And then we're going to do negative 3. 1, 2, 3. And it's good to line them all up. This way when they cancel out, you know what's remaining. So basically we have 3 that canceled out. 1, 2, 3. Leaving us with 2 positive. Therefore, the answer for this one is going to be 5 plus negative 3 equals positive 2. Okay, now let's go to the other problem over here. And we have negative 4 plus 2. So we're going to do 1, 2, 3, 4 negative signs. And with positive 2, we have 1, 2. Remember how I said to line them up? This way they could cancel out. So this cancels out, this cancels out. So then we have negative 2 for your answer. So let me get that. So negative 4 plus 2 equals negative 2. Now we're going to do the number line. And then for the number line, you always want to start at 0. Always start at 0. Okay, so we're going to do negative 2. So we're going to go start at 0. We're going to go 1, 2, okay, plus 5. So then we're going to do plus 5 from here. And we're going to go 1, 2, 3, 4, 5. So then we end up on the 3. So therefore, negative 2 plus 5 equals positive 3. Now let's do one more. We're going to do positive 4 plus negative 2. So let me switch the color so it doesn't get confusing. We'll do purple and green. Let's see. So positive 4, we're going to go 1, 2, 3, 4, making it bigger so it stands out. Okay, so we ended up on 4. And then we're going to go over to negative 2. So we're going to go back 2. So then we're going to go 1, 2. Okay, so 4 plus negative 2 equals positive 2. Okay, so that's how you use the 3 models, well, at least a few of them, with the integer addition. Lastly, we're gonna go over the addition rules, or actually there's one more thing after that. If you have a positive plus a positive, the operation you use is gonna be to add. The answer sign will be a positive, and a quick example would be 4 plus 2 equals 6. Next, we have a negative plus a negative. You're gonna add for the operation. The answer sign will be a negative. Then we have, for a quick example, -5 plus -2 equals -7. Then we have positive plus negative. The operation to use would be subtraction. You're going to use the sign of the integer with a bigger sign. So, for example, 6 plus -5 would be 5. The one that has a bigger sign would be 6 because it's a bigger number. So therefore your answer is going to be 5. Next, you're going to have negative plus positive. The operation to use would be subtraction. Use the sign of the integer again with the same one, with a bigger sign. This would be -7 plus 3. This is the bigger number, right? So therefore, because that's the bigger number, it's going to be -4. Okay. Now we're going to go over the integer addition properties. Basically, let me see, 1 second. Okay, so there are 1, 2, 3, 4, 5, 6 integer addition properties that we go by. So closure property basically tells us that A plus B equals or is a unique integer. Okay. Next, we have commutative property. Commutative property. And commutative property tells us that A plus B is equal to B plus A. An example of this would be 1 plus 2 equals 2 plus 1. Okay. Now we have associative property. An associative property tells us that A plus B plus C is equal to A plus B plus C. Okay, an example of this would be 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. They would both equal each other. Okay, then we have identity property. Identity property tells us 0 is a unique number, the unique integer. The additive identity is such that for all integers, A 0 plus A is equal to A, which equals A plus 0. Okay. Now we're gonna go over the additive property. The additive, I forgot to put inverse. Additive inverse property. Okay, and the additive inverse property tells us that for every integer, A, there exists a unique integer, -A. The additive inverse of A such that A plus A plus -A equals 0 equals -A plus A. Okay, so that would be the additive inverse property. Last, we're gonna go over the property of equality. The property of equality tells us that A equals B, that if A equals B, that if A is equal to B, then A plus C is equal to B plus C. Another way to write this would be negative A plus negative B equals negative A plus B. Okay, and this completes our lesson for today. Please let us know if you have any questions.